My name is Vassili, and I'm working for United Institute of Informatics, what is part of our National Academy of Sciences of Belarus. I'm heading department which is called Biomedical Image Analysis. The major direction is developing new methods of automatic generation of biomedical images. They should be exactly like real images, like computer tomography images, X-ray images, ultrasound images, etc. But they should be artificial. Recently, there is a huge proliferation, huge progress of new methods of image recognition and image analysis, which are based on so-called artificial intelligence. Actually, artificial intelligence in this sense is nothing but deep learning methods, which are implemented as by way of training of so-called convolutional neural networks. The most difficult side of this new technology is that we need to collect a huge amount of medical data to train neural network for medical diagnosis tasks. That's first ethical problems, which are obvious, and second is legal problems because of certain limitation of which exist on dealing with that information, and third, a lot of technical problems as well. Using the same technology, deep learning and artificial intelligence technology, we want to generate images which are undistinguishable ultimately from real ones. So then we would be free to do any kind of research based on this artificial data. This technology is based on so-called generative adversarial networks, and we are very much constrained to use recent very powerful computational facilities such as supercomputers and graphic cards, etc. And we are happy that EaPConnect project provides us some resources in Europe, supercomputing, for doing research and development in this field. There is a very specific way for attacking deep neural networks. So in fact, this is not like a traditional computer viruses, but it's new technology, so-called adversarial attacks. By very tiny modification of original images, we can force deep neural networks to wrong decision. For instance, if the person is healthy, it's possible to modify a little bit image that neural network would say it's cancer, but not normal, or vice versa. In case of cancer, we can modify a little bit original image, and artificial intelligence will say this is normal instead of cancer. Just develop a new method and new software for practical applications for diagnosis. In particular, we are dealing with images of lung. So we're dealing with lung disease, automation of processes of diagnosis and improving them, and developing new methods and technologies for cancer diagnosis based on so-called histology images, microscopy images. Our students also doing research and some development in the field of artificial intelligence, and they also need computational resources. So this is again thanks to European countries which support us on giving resources for computation. There is no limit for using computational power. We are solving some problems because we have enough computations. But some problems we're still not able to address simply because we have not enough computational power. What I want also to say that we are also very much thankful to Eastern Partnership for funding our communication, physical communication, our visits to Europe, because we are limited in that funding. And that's very important to join forces, research facilities and brains to attack the recent problems of automation of medical research.